hayaang buksan ang isipan.
Sa science o agham, tayo na sa Sineskwela. Tuklasin natin ang siyensya,
Buksan ang pag-iisip.
tayo'y likas na scientist. Tayo na sa Sineskwela. Tuklasin natin ang siyensya, kinabukasan ng ating bayan, siguradong makakamtan.
Ang galing ng mga inhinyero, no? Sa hirap ng engineering, nakuha nilang makapagpagawa ng mga buildings kagaya nito, no? Na magagamit ng mga estudyante sa kanilang pag-aaral.
Tama! At isa sa mga konsepto na dapat pag-aralan ng mga civil engineers ay ang shear and moment diagrams. Ito ay para masigurado na ang mga structures na ito ay kayang sustain ang mga applied loads kahit gano'n pa karami.
Wow, ang galing! Gusto ko tuloy malaman kung paano at mapalalim ang aking kaalaman sa shear and moment diagrams. Maaari niyo po ba ako tulungan?
Oo naman, halika, puntahan natin sila Sir Adonis at si Ren Ohta para mas mapalalim pa yung knowledge natin. Sir! Hi! Andyan po pala kayo? Kumusta kayo? Kumusta na po kayo?
Oo, kayo pala yan. Kamusta naman ang pagiging civil engineering students niyo?
Sir, ang ilang mahal ng engineering? Tres lang, masaya na kami ngayon.
Normal lang yan. Sige, ba't napunta pa na kayo dito?
Ito kasi kaibigan namin, sir, gusto niyang matuto ng shear and moment diagram. Siyempre, kami na rin po.
Oo, a very interesting topic. Sige, mapunta kayo para mas magaling natin.
Thank you po.
Before we start, let us first discuss one important concept in this lesson, at ito ang beam. The term beam refers to a slender bar that carries transverse loading, that is, the applied forces are perpendicular to the bar. Sa loob ng isang beam, meron tayong internal force system na binubuo ng shear force at bending moment na kumikilos sa mga cross-section ng bar.
Sa ating pag-aaral ng mga beams, mahalaga rin na pag-aaralan natin ang iba't ibang uri ng mga suporta na kanilang kinasasandalan. Ito ay naglalarawan kung paano tinutulak o sinusuportahan ang isang beam at kung paano ito kumikilos sa reaksyon ng mga suporta. Una sa lahat, mayroon tayong simply supported beam. Ito ay may isang pin support sa isang dulo at isang roller support sa kabilang dulo. The pin support prevents displacement of the end of the beam but not its rotation. The term roller support refers to a pin connection that is free to move parallel to the axis of the beam. Hence, this type of support suppresses only the transverse displacement.
Pangalawa, mayroon din tayong cantilever beam. Sa ganitong uri ng beam, ito ay nakakabit sa isang matibay na suporta sa isang dulo at ang kabilang dulo nito ay malaya. The built-in support prevents displacement as well as rotations of the end of the beam. At panghuli, mayroon din tayong overhanging beam. Ito ay sinusuportahan ng isang pin at isang roller support at ang isa pareho sa mga dulo ng beam ay maabot sa labas ng mga suporta. Ito ang uri ng beam na madalas natin makita sa mga tulay o mga platform na may mga labis na parte sa gilid.
These three types of beams are statically determinate because the support reactions can be found from the equilibrium equations. Sa kabilang banda, ang mga prop cantilevered beam, fixed or restrained beam, at continuous beam ang mga halimbawa ng statically indeterminate beams kung saan hindi sapat ang mga equations ng equilibrium upang makuha ang reaksyon sa mga suporta. Tumungo naman tayo sa mga procedures sa pagdetermine ng shear force at bending moment diagrams. Ang method na ito ay by equation kung saan hinahati ang bawat beam sa bawat segment na mayroon ito at kinukuha ang shear and moment equations nito.
Una sa lahat, kailangan natin compute ang mga reactions mula sa mga supports mula sa free body diagram ng buong beam. Ito ay makakatulong sa atin na malaman kung paano ito sumusupil o sumusuporta sa mga persang inilalapat sa kanya. Pagkatapos, kailangan nating hatiin ang beam sa bawat segments upang mas madaling masuri ang loading ng bawat bahagi. Dito natin gagamitin ang mga cutting plane para hatiin ang beam sa bawat bahagi. Sa bawat segment ng beam, gagawin natin ang mga sumusunod na hakbang.
Una, mag-i-introduce tayo ng imaginary cutting plane sa loob ng segment at dito natin hahatiin ang beam sa dalawang bahagi. Pagkatapos, gagawa tayo ng free body diagram para sa bawat bahagi ng beam na naiwan pagkatapos ng pag-cut. Dito natin ipapakita ang shear force at bending moment na kumikilos sa kanilang mga positibong direksyon. Matapos, gagawa tayo ng mga ekspresyon para sa shear moment at bending moment gamit ang mga equation na equilibrium mula sa free body diagram. Ito mga ekspresyon para sa mga shear force at bending moment na kalaliwang mga functions ng distance x mula sa isang dulo ng beam.
At panghuli, ipaplant natin ang mga ekspresyon para sa V at M para sa bawat segment ng beam. Mahalaga na gawing visual at komprehensibo ang pagpaplat nito upang mas maintindihan natin ang pagkilos ng beam sa iba't ibang punto. Sa ganitong paraan, may papakita natin ang mga shear force at bending moment diagrams ng isang beam na makakatulong sa atin na masuri at maunawaan ang kanyang pagtugon sa mga puwersang inilalapat dito. These diagrams are usually discontinuous and or have discontinuous slopes at the endpoints of the segments due to the discontinuities in loading.
Now let's proceed with an example of bi-equation to get the shear and moment diagram. The problem is the simply supported beam in the figure below supports a 30 kN concentrated force at B and a 40 kN meter couple at D. Sketch the shear force and bending moment diagram by the equation method. Neglect the weight of the beam. The first step is to determine the unknown forces given by the reactions of the supports in the beam. That is the AY at point A and the EY at point E. So we need to use the equilibrium of equations that specifically the moment. So moment at A is equals to 30 multiplied by 4, that is our concentrated force, and it is positive because it moves clockwise, plus 40, which is our couple that moves also clockwise, minus our EY multiplied by its distance, which is 10, is equals to 0. That could yield us with a value of EY, which is 16 kilonewtons. And then we also need to find the moment at E to get the value of AY, that is negative 30 multiplied by 6, since it moves counterclockwise, that's why it is negative, plus 40, which is our couple, plus AY multiplied by its distance, which is 10, is equals to 0. That could give a value of 14 kilonewtons for our AY. Next, the next step is to use an imaginary cutting plane to cut the segment of the beam into two parts. So that is to use imaginary cutting plane at AB, at BD, and at DE. So at segment AB, our present forces are 14 kilonewtons, which is the value of AY. Therefore, our shear moment, which goes downward, has a value of 14 kilonewtons because our present forces is 14 kilonewtons only, and it goes upward. Next, for our moment, which is our MAB, our bending moment will be 14 multiplied by the distance of the segment which nakat nga kanina, and yung distance niya is x. So our moment is 14x since our present force, which is the 14 kilonewtons, moves clockwise. Next, for our segment BD, we will use again an imaginary cutting plane to cut the segment, and then the only present forces are the 14 kilonewtons and then the 30 kilonewtons, which is the concentrated force given. Our 14 kilonewtons goes upward, therefore it is positive, and our 30 kilonewtons concentrated force goes downward, therefore it is negative. Therefore, our VBD, which is the shear force at this segment, is equals to 14 minus 30 is equals to negative 16 kilonewtons. For our MBD, which is the bending moment, it is equals to 14 multiplied by the distance of the segment, which is unknown, that could be represented by the variable x, so therefore it is 14x minus 30, which is our concentrated force that goes or that moves counterclockwise, multiplied by its distance. What's its distance? It is x minus the distance from the A to B, which is 4 meters. Therefore, the distance of the concentrated force from the point we get the moment is x minus 4. That is 14x minus 30 multiplied by x minus 4. Next, for our segment DE, we will use again an imaginary cutting plane to cut the section of this segment, and then the present forces for this segment therefore is 14 kilonewtons, 30 kilonewtons, and the couple, which is 40 kilonewtons meters. Therefore, our VDE is equals to, again, positive 14 minus 30 is equals to negative 16 kilonewtons. And lastly, for our MDE, it is equals to, again, 14 multiplied by x since it moves clockwise, and then negative 30 multiplied by x minus 4 as explained earlier, and then plus 40, which is our couple. It doesn't need a distance because it is already a couple. Therefore, the value of this one is equals already to force times d. So that's why its unit is kilonewtons meter already. Next, our next goal is to find the value of the
points for each segment. That is, for example, at segment AB, since it is from 0 to 4, we will substitute the value of 0 and 4 for the equations na nakuha natin. That is, when x is equals to 0, our VAB is simply 14 since wala namang variable na x sa VAB natin. And then for our MAB, since it is 14 multiplied by 0, it is equals to 0. When x is equals to 4 naman at segment AB, our VAB is still 14 kilonewtons because our VAB is 14. There is no variable x to substitute. And for our NAB, it is 14 multiplied by 4 is equals to 56 kilonewton meters. Next, for our segment BD, which goes from 4 to 7. When x is equals to 4, our VAB is equals to negative 16 kilonewtons because there is no variable x again to substitute 4. And then for our MAB naman, it is 14 multiplied by 4 minus 30 multiplied by 4 minus 4. That could give us MBD at point 4 is equals to 56 kilonewton meters. And then when x is equals to 7 naman, our VAB is still negative 16 kilonewtons because again there is no variable x. And then for our MBD, when x is equals to 7, it is 14 multiplied by 7 minus 30 multiplied by 7 minus 4. That could give us 8 kilonewton meters. And lastly, for our segment DE, when segment DE, it is from 7 to 10. That is, when x is equals to 7, our VAB is still negative 16 kilonewtons because again, there is no variable x to substitute. And then for our MAB, it is 14 multiplied by 7 minus 30 multiplied by 7 minus 4 plus 40. That could give us MD is equals to 48 kilonewton meters when x is equals to 7. And lastly, when x is equals to 10, our VDE is still equals to negative 16 kilonewtons. And our MDE is equals to 14 multiplied by 10 minus 30 multiplied by 10 minus 4 plus 40 is equals to 0. Next, we will plot those values na nakuha natin sa ating shear and moment diagram. So for our shear diagram, it starts with 14 kilonewtons, then at x is equals to 4, it is still 14 kilonewtons, and then it goes down to negative 16 kilonewtons, and then when x is equals to 7, it is still negative 16 kilonewtons, and when x is equals to 10, it is still negative 16 kilonewtons, and then it goes upward to 0. Next, for our moment diagram, it starts with 0 kilonewton meters, and then when x is equals to 4, it goes up to 56 kilonewton meters, and then when x is equals to 7, it goes down to 8 kilonewton meters, and then it goes up to 48 kilonewton meters, and then when x is equals to 10, our moment is 0.
Okay na.
Go. Sobrang galing naman pala ng method by equation. Ngayon natutunan ko na paano gamitin ito.
Oo nga, sir. Pero wala bang mas mabilis na way para kunin ang shear and moment diagram?
Mabuti na itanong mo, Faith. Ang area method ay isa pang mas madaling paraan upang makuha ang shear and moment diagram. May papaya kong puntahan si Miss Ohta upang ituro ito.
Okay po, sir. Maraming salamat po sa tulong niyo. Pupuntahan ako natin sa Sineskwela. Hi, ma'am!
Oo na, no? Tres Marias! Nasakit yung mechanics, ma'am?
Wapin po?
Diyos ko naman! Lenang kayo, kasagiyay tayo! Mechanics, basic!
Hindi ka naman, ma'am. Ma'am, bisa kami paturo. Mamumurit na kami.
Oo, tala. Sipo ka na lang. Hindi. Sa ating pag-aaral ng mga shear at moment diagrams, may isang paraan na tinatawag na area method. This method allows us to quickly and precisely draw shear and moment diagrams by analyzing the areas under the load curve. First, let's discuss the procedure for creating the shear diagram using the area method. So, ang unang gagawin, identify the loading o yung reactions. Pangalawa, draw the load curve. Pangatlo, compute the shear force. So, sa paggamit ng graph, maaari natin kunin yung mga forces by points. So, ang plus, plot the shear diagram. Ang mga positive shear ay itataas, however, yung mga negative shear ay ibababa. Next, let's move on to the procedure for creating the moment diagram using the area method. So, ang una ulit, compute the area under shear diagram. Gamit ang shear diagram, kailangan natin kuhanin ang mga halaga ng area sa ilalim ng curve para sa bawat segment ng beam. Pangalawa, compute the moment. Ang moment sa isang segment ay katumbas ng pagbabago sa area ng shear diagram mula sa dulo ng segment. At pangatlo, plot the moment diagram. Sa paggamit ng mga computed moments, plot natin ang moment diagram. Now, let's have the same example used by Sir Cayanan a while ago, but this time, using the area method. So, based sa discussion nyo with Sir Cayanan a while ago, ang nakuha nyong AY is positive 14 kN at ang EY naman is positive 16 kN. So, next ang gagawin natin, kukunin na natin yung shear diagram using area method. So, sinabi natin kapag ang may present na force sa point A na positive, itataas. So, positive 14 kN. At dahil wala namang force na nakapagitan sa A to B, mananatili siyang 14. Kapag naman point B, dahil meron na tayong negative 30, so ang mangyayari nun, 14, negative 30 is equal to negative 16. At dahil sa point B to D at point D to E, wala naman siya nakapagitan na force, mananatili siyang negative 16 all throughout. At hindi tayo nagtatapos dyan. Meron tayo sa point E na positive 16. So, negative 16 plus positive 16 is equal to 0. At dahil nakuha na natin ang shear diagram, magpo-proceed tayo sa moment diagram. At dito, magbe-base tayo sa mga areas na nakuha nating figure. At makikita naman natin sa shear diagram natin na ang area 1, area 2, at area 3 natin ay rectangle lahat. So basically, lahat ng formulas nun ay length times width or base times height. So mag-i-start na tayong mag-plot. Sa point A, dahil wala namang present na couple, so x is equal to 0. At dahil yung area 1 ay may present tayo na 14 at ang distance natin na 4, at pagta-times natin yon is equal to 56. So, point A hanggang point B, aakyat tayo ng 56. So, sa area 2 naman natin, ang present ay negative 16 at ang distance natin na 3, so is equal to negative 48. So, 56, negative 48 is equal to 8. At dahil sa point D, meron naman tayo dito na present na couple which is the 40 kilonewton. So, 8 hanggang 8 plus 40 is equal to 48. Kapag nasa point D na tayo at papunta na siya sa E, dahil meron na naman tayo na area 3 na negative 16, tapos ang distance natin ay 3 is equal to 48. So, negative 48 plus 48 is equal to 0.
Ma'am, makanya mo pala yung area method, kasali na pala.
O ma'am, yun yung buto na ng TVG. May langola na rin ang tahanan, pinakasasaya. O, then Tres Marias, ng kanya benda, tayo sa benda, chichismis ko mong chichismis.
Kaya naman, ma'am, mami mo kami po.
Oh, ma'am! Thank you po!
Wala na kami, ma'am. Thank you po.
Sabi na po pala yung area method.
Okay, goodbye.
Okay, ma'am.
Ang dami kong natutunan sa shear and moment diagram sa araw na ito. At sana'y kayo rin. Lubos na pasasalamat ko sa aking mga kaibigan sa patuloy naming pagsubok kahit mahirap ang kursong ito. At sa mga instructors naming masipag at magagaling. Hanggang sa muli, paalam!
Tayo na sa Sineskwela, tuklasin natin ang siyensya, kinabukasan ng ating bayan, siguradong makakangla.
Sa Sineskwela, tuklasin natin ang siyensya.
Daigdig ay sasaya.